We see stars all around, so why doesn't their combined light add up to make our night sky and surrounding space for that matter bright? German physicist Heinrich Wilhelm Olbers put the same puzzle this way in 1823. In the universe is infinite in size, and stars or galaxies are distributed throughout this infinite universe. Then we are certain to eventually see a star in any direction we look. As a result, the night sky should be aglow. Why isn't it? In fact, the answer is far more profound than it appears. There have been many attempts at explaining this puzzle. Dubbed Olbers' paradox over the years, one version implicated dust between stars and perhaps between galaxies. The idea was that the dust would block the light from faraway objects, making the sky dark. In reality, however, the light falling on the dust would eventually heat it up, so that it would glow as brightly as the original sources of the light. Another proposed answer for the paradox held that the tremendous redshift of distant galaxies, the lengthening of the wavelength of light they emit due to the expansion of the universe, would move light out on the visible range into the invisible infrared. But if this explanation were true, shorter wavelength ultraviolet light would also be shifted into the visible range, which does not happen. The best resolution to Olbers' paradox at present has two parts. First, even if our universe is infinitely large, it is not infinitely old. This point is critical because light travels at the finite, though very fast, speed of about 300,000 kilometers per second. We can see sometimes only after the light it emits has had time to reach us. In our everyday experience, that time delay is minuscule. Even seated in the balcony of the concert hall, you will see the conductor of the symphony raise her baton less than a millionth of a second after she actually does. When distances increase though, so does the time delay. For instance, astronauts on the moon experience 1.5 second time delay in their communications with mission control due to the time it takes for radio signals, which are the form of light, to travel a round trip between Earth and the moon. Most astronomers agree that the universe is between 10 and 15 billion years old, and that means that the maximum distance from which we can receive light is between 10 and 15 billion light years away. So even if there are more distant galaxies, their light will not yet have had time to reach us. The second part of the answer lies in the fact that stars and galaxies are not infinitely long-lived. Eventually they will dim. We will see this effect sooner in nearby galaxies. Thanks to the shorter light travel time, the sum of these effects is that at no time are all the conditions for creating a bright sky fulfilled. We can never see light from stars or galaxies at all distances at once. Either the light from the most distant object has not reached us yet, or if it has, then so much time would have had to pass that nearby objects would be burnt out in dark.